Welcome. My name is Shannon Jackson. I have the privilege of serving as Associate Vice Chancellor for the Arts and Design here at Berkeley, where my role is about synchronizing and mobilizing our incredible creative landscape on campus and off. And it's my privilege to welcome you today to the first in our lecture series, A+D Mondays, Arts plus Design Mondays, a series that many of you know is co-curated by a number of departments, centers, schools, and artistic organizations throughout Berkeley in collaboration with Bay Area partners. The Monday series always welcomes the people and ideas that most compel the Berkeley faculty and students, those of us who care about the role of the arts and design, culture, and humanities, engaging with the biggest questions that we have upon us across political sectors, across technological sectors, urban sectors, and more. So, indeed, this particular year, we have an even more ambitious reach because the effort has been amongst me and my colleagues to guide our engagement around arts and creativity and technology to thinking about some very big ideas that are currently structuring our campus strategic plan. Some of you may know that we're in the process at Berkeley of imagining a new strategic plan, and we as a collective faculty all throughout the campus have started to alight upon 5 huge research themes that might guide the next couple of decades of research at Berkeley. I'll say the 5 quickly here: the future of the environment, the future of health, the future of democracy, the future of equity, and the future of so-called artificial intelligence, we say inclusive intelligence. And the effort here has been to ensure that the arts, design, humanities, cultural questions are engaged in every single one of those 5 core big ideas. What is the role of the arts? What is the platform we should be creating in order to be sure that the arts have a vital role in each of them? We're going to be thinking about all of them throughout the year, and thinking in particular about democracy, equity, and so-called intelligence. And you'll note that, especially, I think, from what you'll hear today. We're going to be asking about the role of the arts in catalyzing social justice. We're going to be thinking about how conceptions of creativity, democracy, equity, and what it means to be human are changed by ever new technologies, all while trying to galvanize and think about the future of our public university and its contribution to the world. I'll say, as I begin what is now my 5th year of a 5-year appointment as in the current administrative role that I have here at Arts and Design, I find myself recalling that the creation of this series was as much about logistical reasons as it was intellectual and artistic reasons. As many of you know, if you're here at Berkeley, we have an incredible array, a huge, diverse array of creative organizations, departments, centers, museums, presenting organizations, laboratories, workshops, makerspaces, all of whom make up this incredibly diverse campus, but sometimes it can be hard to find them all. Sometimes it can be hard to coordinate them all, especially if you're a new student or a prospective student. So my colleagues and I, a few years ago, started to think, what if we could have a major, huge, mega website that would gather all of the different departments and opportunities in one place, so you didn't have to check 50 when you arrived. So the Arts and Design website was born, and it's stewarded now by our incredible communications director, Sarah Fullerton. Also, around that time, we started to think about the number of events, symposia, exhibitions, screenings, talks that are curated by our incredible departments and centers all throughout campus, sometimes at odd and inconsistent times, sometimes in conflict with each other, so you would have to choose. So colleagues and I also started to think about what if we could create one big, major, mega lecture series curated by a number of organizations at once, and A+D Mondays was born and is continually reborn every week thanks to the incredible, good-humored, visionary collaboration of so many faculty and staff, including A+D staff members such as Catherine Wallerstein and Paris Coates, and many, many of the faculty and staff that are gathered here. Now, it is also a moment to reflect about how much what we were doing at A+D is not always creating new programs, but about integrating and elevating programs and incredible organizations and people that are already here, who are already here, and that is so much of what the effort has been. And with that in mind, I also have the chance to reintroduce one of those incredible organizations, the Berkeley Center for New Media, that is an organization that is always such an incredible co-producer and co-conspirator. As many of you know, BCNM is a research laboratory, an educator, a convener for thinking about ever new media, and sometimes old media, and their various effects on the human landscape, on the social landscape. As it happens, this month also marks the beginning of the tenure of its new director. BCNM has a new director in Abigail DeKosnik, whose interdisciplinary research and generous spirit are also always serving as incredible glue function. Welcome, Gail. You're going to see her up here many times. Also, well, I won't call him old. I will call him prescient. There's another individual in this room that I want to welcome and introduce, someone whose presence reminds us that before there was A+D, before there was BCNM, there was the Art, Technology, and Culture Colloquium, founded over 20 years ago by Ken Goldberg, that has served ongoingly and before lots of others were doing it, as a place to think about the catalytic, bracing, contradictory, controversial, productive role amongst arts and technology and culture, and now serves as a sort of North Star for helping us think about the nature of intelligence, the nature of media, the nature of what it is to be inclusive. So without further ado, and also to help set the scene, I am so pleased that ATC is always a part of the A+D Monday series, and it's due thanks to the visionary leadership of an individual who makes Berkeley great. Please help me welcome Ken Goldberg to set the scene and introduce our speaker.
Thank you so much, Shannon. You're always amazing, even with two sprained legs. So I'm thrilled to see the turnout tonight, and I want to welcome you all to the 209th lecture in the Art, Technology, and Culture series. Now, as Shannon just alluded, speaking of so-called intelligence, this weekend we learned of some shocking lapses in judgment by leaders of research and new media. This crass indifference to human suffering is a timely reminder and wake-up call that nothing justifies taking advantage of other human beings. The acts that were exposed and the associated linkages violate every fundamental aspect of our ethics. Going from the Golden Rule to Immanuel Kant to Martin Buber, the idea of just crassly ignoring the vulnerability of other human beings is so troubling. Today, more broadly, the increasing in popularism, inequality, xenophobia requires us to reconsider our assumptions about labor, trade, political stability, education, and community. It was a century ago, in the year 1920, that Karl Čapek coined the term robot in a play about mechanical workers organizing a rebellion to defeat their human overlords. Today, advances in artificial intelligence and robotics, fueled by corporations and venture capital, challenge our assumptions about power, equity, fairness, and the distinctions between humans and machines, and between ourselves and the other. As summarized by Edward Said, the idea of Orientalism is a process of disregarding, essentializing, and denuding the humanity of another culture, people, or geographic region. More broadly, the idea of exoticism would include those and also others, such as gender and class. So the theme for this year's Art, Technology, and Culture series is, we're calling it Robo Exoticism. It characterizes a range of human responses to AI and robots that exaggerate both their negative and positive attributes and reinforces fears, fantasies, and stereotypes. The series will include a number of speakers, including Guy Hoffman, Leonor Mora, Amy LeViers, Margaret Ree, Tom White, and tonight, to kick the whole thing off, we're thrilled to have Madeline Gannon. Dr. Gannon is a multidisciplinary artist. She earned a master's in architecture from Florida International University and a master's and Ph.D. from Carnegie Mellon University. She has been artist in residence at the Autodesk Center in Pier 9, and now leads the Atonaton Research Studio with Julianne Sandoval in Pittsburgh, Pennsylvania. Her work has been exhibited in the US, in the UK, in China, major centers of world turmoil, as we know. And she's won the Acadia Award for Innovative Research. As we'll see tonight, Madeline has a way with robots. She somehow is able to coax out of them some graceful, lyrical motions that create empathy akin to the most exquisite ballet. Robots are creatures, not things. Her title tonight conveys her sensitivity to the nuances of how each of us relates to others in ways that can never be neutral. Please join me in welcoming Madeline Gannon.
I'm absolutely delighted to be here today to help kick off this series and to help welcome the new semester. And as always, I love talking about robots, so it's always a good day. It's wonderful to be a part of this lecture series, ATC. Especially, Ken, I think you've curated a lot of really brilliant minds, a lot of friends and colleagues whose work I deeply admire. And I really wish I could be here the whole semester to hear them. So I think you have a good program for the rest of the semester ahead of you. So my name is Madeline Gannon, and I'm passionate about inventing better ways to communicate with machines. And I explore the future of our world with robots in a kind of unconventional way through many different lenses. So I take a multidisciplinary approach. For me, I've been called many things: a designer, a researcher, an artist, a scientist, an engineer, and I try to embody and cherry pick the best of those disciplines, the best practices from each of those disciplines, to sort of get at an idea, look at the things that are overlooked or underexplored in an emerging technology. And for the past couple of years, that's really focused a lot on robotics. We're going to talk a lot about robots today, but because there's so many people here in this room that I imagine are still trying to find their way with how do you combine all your creative energy with this technical field of software engineering and robotics, or vice versa. If you come from the technical side, how do you begin to employ the arts in what you do? I wanted to start first just by sharing a little bit of my journey and how I sort of wandered over from architecture and design into computer science, human-computer interaction, and robotics. Because there was no plan, really. I just kind of followed my feet over there and wandered into it. So just to start, this is really where I got my start at architecture school in Miami. And architecture provides a really amazing education. I mean, it shows you how to imagine things that don't exist and then how to convince people that they should exist. And that's a really, really powerful tool. And with that, you do learn some technical things. You learn a lot about 3D modeling software, digital tools for imagining and creating things, and also communication tools. And at the very end of my degree program, my university got this amazing thing, and something kind of unexpected happened to me, and I kind of fell in love with the machine. So the very last semester, I had never really stepped into the wood shop before, but lo and behold, here's this CNC machine, this Techno 4848 CNC machine that could take all of my digital creativity in 3D modeling and virtual geometry and translate something out into the physical world that I could tangibly hold. It was really like the first time I made a physical thing that wasn't out of chipboard and paper and laser cut material. Was really with this thing. And it was just so intoxicating and empowering to be able to bring a thing out of my mind through a computer and into the physical world. So this is some of the first stuff that I made, is sort of making geometry and having this machine carve it out of a material. And as you can see, like this machine in general is used for cabinet makers. I think that's the most common use of it, of a CNC router. And so I sort of wondered to myself, well, if I could carve something out of wood, could I also draw with this machine? And it turned out I could. I could make some drawings with it. But not without like some strict coercion of this, duct taping things together and kind of MacGyvering a solution for this. Because at the end of the day, I wanted to do something with this machine that the software that ran it had no intention of supporting. Like, why would you use a cabinet making machine to draw stuff? That's just absurd. And what I realized is that if I wanted to do creative things and push the boundaries of what this technology could do, then I would really have to learn how to talk to these machines. And so I left Miami, I moved to Pittsburgh, and I set off to figure out how I could talk to these machines. And at the beginning, I was really limited. I mean, this is kind of like you make geometry in a computer and you feed it to a machine in a certain way. And by using the tools that someone else had made, I was kind of limited by their worldview for how I should operate in it. And in learning how to program, I was starting to be able to do things that commercially available tools just weren't able to do, like play around with a form and splash it around, and using physics simulation to design something, to freeze it in time and then carve it out of wood later. So these own interactive tools were something that I couldn't find out there, but I had the means to begin to stitch together and make and create. Another thing that kind of blew my mind that I really didn't know about when I first started is that computers can actually see you, and that's an amazing thing. It's kind of obvious now, but at the time, I was like, whoa, a computer can see me, it knows what my face is. And when you connect that and to geometry, all of a sudden you can interact with the virtual world with more than just a keyboard and a mouse. And that led me to more ambitious projects to try to figure out how I could actually like reach into the digital world and literally sculpt intricate forms around complex canvases, like this virtual scan of my own body, and then get those out to a fabrication machine, get it out again into the physical world, and then be able to put it back on the body in really innate ways. So over time, as my technical capabilities improved, as the confidence in my technical abilities improved, I was able to really leverage my experience as a designer to make new contributions in computer science and human-computer interaction, because I had this secret superpower that other people didn't have. So this, for example, is a software program I designed that let you 3D model directly on your body, and it's detecting touch interactions with your skin to make this smartwatch band that can then be fed through a 3D printer and put back on. And for everyone who's sort of struggling out there to figure out like how do you fit, how do you contribute into this world of art and technology, how do you find that intersection that you can occupy and expand and contribute to, there's a bit of a learning curve in reaching to the other discipline, but at the end of the day, you have to have confidence in the knowledge that you innately bring to that table and combine it in unique and interesting ways. And at the same time, the fabrication facilities I was working with also had industrial robots, and these are just, in my mind, they were just another fabrication machine. a CNC router has 2.5 axes, a 3D printer has 3 axes, and a robot arm has 6 axes. It's just another way. You give it geometry and it moves. And then I had the good fortune of helping out an artist in residence at Carnegie Mellon complete a project that she was doing while in residence. And this is a piece by Addie Wagenknecht called Optimization of Parenting, Part 2. And she asked me to help her program this robot to gently rock this bassinet, and when the baby cried, to like rock a little harder there. And this was a really formative moment for me because it was the first time that I was presented with an idea that I don't have to use this machine that makes things to make things. This machine has so many other abilities and so many other symbolism and metaphors and even just like technical abilities that to dig into and really explore what we've overlooked. And so, after that, I made this project with a friend that turns that same robot into a back massager. So when you get really annoyed and tired of programming it and frustrated at it, you hit play and it gives you a good back massage. And now you can see we're drifting back into the robot sphere, right? So today I'm gonna talk about a couple robot projects, but it's really that journey from design and architecture into robotics and into computer science really gave me a different lens to explore some of these same questions that we're asking across all these disciplines with these machines. And for me, I didn't really ever approach it from the perspective of automation, but I was sort of already tinged to look at the human body in relationship to the machine and on interaction as well as another lens that I sort of look through. So I told you we're going to have lots of robots today. So I'll talk about these a little bit better, but just so you know a little bit more about me as we spend the next hour together, and hopefully the good news and the bad news is that there's no rules in how you begin to combine creative and technical energies into a new thing. The bad news is that there's also no roadmap for it. So let's get going. And I like to start off thinking about what is a robot? It's an easy question, a fundamental question, but when you close your eyes and you think of a robot, what is the image that comes into your mind? And chances are, I'm gonna guess it's one of these. Okay, so maybe you think of something like Asimo, like this kind of animatronic demonstrator that walks up these endless stairs, or tries to. Or maybe you think of C-3PO, these kind of pillars of our pop culture and science fiction. Or maybe if you're have been on the internet lately, maybe you've seen these impressive, kind of unnerving demonstrations coming out of advanced research labs like Boston Dynamics. But I think that with these robots, they are all robots, but it's also a very narrow definition of what a robot is. And for me, I like to expand that out. I think, for me, a robot is anything with a mechanical mind and anything with mechanical muscles. And when you think about this expanded definition, we can see that there are already many species of these machines living amongst us. So with that definition, we can see that there are robots in factories and warehouses, that we already have robots in our cities, our streets, and our skies. I walked across a couple here on Berkeley's campus, actually, little Kiwi bots. If you're in a hospital, you're likely to bump into a robot that is delivering supplies and to different hospital rooms. If you're in a library, you might even be sitting next to a 3D printer, which is just another robot out there. Or you might have one cleaning your apartment or home or entertaining you. And so the future that we imagine is already starting to be out here. But the biggest difference is that these guys don't necessarily look like us. They have their own innate anatomies, and for a lot of reasons, these non-humanoid robots don't have really great ways of communicating with us because they're just kind of so different. But we have a long and storied history with robotics, the deep desire that's kind of hardwired into us that goes back all the way to ancient times, across cultures, across Egypt, Greece, and Antioquia, and even China as well. This deep desire to sort of breathe life into the inanimate has been hardwired into our culture from the start. And the very beginnings of what these robots are, this is a mechanical Turk, which is a chess-playing robot, and the Jacquard loom. These are kind of proto-robots that are laid the DNA for what came after it, were also highly influential in how we still think about these machines today. So the mechanical Turk is a chess-playing robot, but instead of being a robot, there's actually a person inside who is secretly a chess master inside the box that's playing against a human. But if you look at this, it's still kind of how we begin to mark what an intelligent machine is. That's the metric that we use. If a machine can best us at a game, then it's intelligent. And that, I think, is also another narrow definition of what intelligence can offer. The Jacquard loom as well is a really interesting piece of technology, first used in textiles. This is where the idea of punch cards came to be, which was the very, very basic building blocks for programming. And the Jacquard loom immediately inspired the Charles Babbage's analytical engine, which is, these are like the common ancestors of computers and robots. This is a robot that is a computer and laid the foundation for that. If we go a little faster into pop culture, these early robots, from Robbie the Robot and Forbidden Planet, to Rosie from the Jetsons, to the robot from Lost in Space, and R2-D2 and C-3PO, that these early robots really do set the standard for what we expect our robots to be. What I hear all the time, I'm very fortunate to be able to travel the world, and one of the questions I get all the time is when are we going to have a Rosie in our house? When are we going to have a maid robot in the house? And if you look at this, this show, the original running of the show was only for a year, and yet it had such a big impact of what we think of our future with these machines, this 50-year-old vision of our future from our past. At the same time that this was happening, there were some really incredible things happening in the art world. And again, this is a very nebulous time where the definition between computer and robot and art and technology was just sort of emerging. And two really influential exhibitions were Cybernetics Serendipity and a group called EAT, Experiments in Art and Technology. And what I love about both of these is that the ideas that are here I find really prescient and kind of overlooked for where we are today with these machines. So you have people making these weird robot creatures that come to you or follow you around a plaza, and then at the very same time you have kind of the original inventions of computer-controlled manufacturing that happened in the late 50s, as well as the very first industrial robot arm that invented in the early 60s and applied on the line in the early 70s, that these are the ways that robots actually came to impact and interact with people on daily lives. When you move a little forward and come into our modern robots, what we're experiencing today, you sort of see a shift in the narrative. So the 1980s really ushered in the cyberpunk era for science fiction and pop culture. And the robots that we see in these TV and films, they look like us, but they're enhanced with these kind of superhuman abilities. And when we look at, I'm cherry-picking some examples here, but when we look at the majority of these, there's kind of this allegorical trope into the storytelling here. So it's man creates machine in his own image, machine surpasses man, man must be destroyed or be destroyed by machine. And that narrative, that binary narrative of them or us, is kind of still in the mix when we think about robots today. And in industry, we've seen a lot of rapid change, but automation still is kind of at the heart of it. So industrial robots are still prevalent, and they have a steady growing and adoption rate across manufacturing across the globe. But they're also starting to get a little more agile and mobile, so for logistics robots or package delivery like we've seen here on campus. We're also starting to see some things happen in the medical field, where there's really amazing surgical robots, things for prosthetics, where exoskeletons are helping stroke patients rehab a little easier, and other assistive technologies are beginning to increase quality of life for many, many people. And then in the domestic sphere, there's a lot of great examples. I mean, you can pick up this robot at Costco now, which is kind of exciting, right? So domestic robots that do chores, that make your life a little easier, social robots that keep you company, and robotic utensils that again, are another assistive technology that can help you if you have tremors, for example, in your hands. All of this really comes to mind for me. I really think that where we're at is that our modern realities of where we are with robots is often way more exciting than the stories we tell ourselves about what robots should be. So this is kind of our expected future with robots, and this is our more like our actual, right? Right? And like, how could we have imagined back in the 50s that this would be our reality today, right? And for me, that's kind of the energy that I'm chasing. That's kind of the realm that I think that probing at the edges of what's possible can get us towards. More of this. So I see sort of a lack of imagination in how we think about our future with machines. And the futurist Stuart Candy has this really, really great diagram that I think explains how we can think about the future in a nice way. So he talks about the possible, the probable, and the preferable future. And we are standing here in the present, and we're looking outwards. And the further out we look, the bigger that cone of what's probable and possible and preferable gets. And for me, I sort of see the role of industry as sort of narrowing in on that probable. They have a responsibility to focus on what is likely going to happen. In research, you have the responsibility to focus on what's possible, all the things in that realm within probable and expansive even more, that what might actually happen. And for the arts, I see that the arts play a role at what's preferable. And this, I think, is a really important distinction, right? It sits at the edge of what's possible, but pushes out towards the unimaginable to get at those futures that we really actually want and not have to settle with the ones we have. And I think about this a lot with when I work with robotics. I think that in general, there is a lack of imagination about how these machines can enhance and engage and augment our lives in really meaningful ways. So I spend a lot of my time working with industrial robots. I am endlessly fascinated with them. Not only do these machines have superhuman strength, superhuman speed, superhuman precision and endurance, like these are all things we describe our superheroes with, but they also tend to live like really, really boring lives, kind of locked up in factories, doing the short, repetitive task over and over again. And they've become pillars of our automation infrastructure. And at that same time, they also have this dual symbolism of everything that we fear about robotics, and oftentimes everything we fear about rapidly advancing technology. They've come to symbolize the fear of our own obsolescence. And when I work with these machines, I try to think about, as a society, we have an astounding agreement on the futures we don't want with these machines. We don't want them to enslave us. We don't want them to replace us. But we've really yet to decide what are the futures that we do want with these machines. And that is a far harder question to answer, and a very, very important one. So this is really at the heart of what I want to share with you today, how, as artists and designers and technologists, we can begin to probe at the edge of what's possible to forge new relationships and new futures with these machines. I'm really passionate about inventing better ways to communicate with machines that can make things. For a long time, industrial robots have been the culprit of automation and replacing human labor. Basically, all the easy tasks to automate have been automated. Now what we're working on is using these tools to enhance or augment human labor. And that to me is very exciting. Industrial robots are really fantastic CNC machines, you put a different tool at the end of the arm, and all of a sudden they can do a whole different thing. So in the morning you can be doing spot welding, in the evening you can be doing painting. It's just highly adaptable. Another thing that I'm working towards is finding ways to bring these machines out of factories and into live environments. So onto construction sites or onto film sets. There's chance for unpredictable objects like people to be moving into the environment. That's one of the reasons why I wanted to build the system, to give this robot eyes so that it could actually see me and we can safely collaborate in a shared space. If I'm wearing or if I'm holding these motion capture markers, it knows where I am in space, it knows how I'm moving in space. Now all of a sudden we can give the machine a nuanced understanding of our intention in that space. You can get someone who's never seen a robot before and have them begin to do creative things with just a couple minutes of interacting with the machine. So a lot of my conversations with robots really revolve around asking them to do things they were never intended to do. So the software I created here as a part of this Autodesk Pier 9 residency was essentially convincing them to go beyond their engineered purpose. So instead of having this machine do short, repetitive tasks, I'm asking it to be open and improvisational even. And so that was the effect that I kind of imposed on this robot. But after kind of hours and days and weeks of standing in front of it, developing the software, I was really surprised about the effect that it had on me. With this big orange robot, I began to feel less and less like a roboticist standing in front of it, feeling it move in front of me, and more like this. Right? Like I was some sort of animal tamer coming face to face with this big orange beast of a machine that was just so excited to follow me around the lab, I have, so the programmer in me understands that, like, no, it's just executing a program. But the spatial relationship and the way that we moved together, the way that it responded to me, I couldn't help but begin to project my emotion onto it, project the connection onto it. And what was really exciting is that other people noticed that too. And one day a curator at a museum called me up and asked me if I could translate that experience, that bond that I felt with this machine, for a whole crowd of visitors to his museum. And in some ways to help those people begin to see that there are other alternatives to our future with automation. And so of course I said, yeah, sure, no problem. No, you need it in 3 months? Yeah, no, that's easy, yeah. But that was a whole other journey of software development after that. But the initial ask, this idea of bringing this machine into a museum for people to begin to engage with, this exotic machine, it kind of reminded me of Victorian era zoos, right? Where you have these strange and exotic creatures from all around the world that were captured and brought into some artificial environment for our own spectacle and amazement. And so that's kind of what I made at the museum. I decided to give this industrial robot a 6-month holiday from its incredibly boring life on a factory assembly line in Birmingham, UK, and have it live at the Design Museum in London to just exist and meet strangers with a curiosity similar to their own. So let me briefly introduce you to my robot here, Mimus. And so here she is, greeting some of the ceiling installers that were also putting up the museum as the exhibition was going around. And the challenge for me was how do I transform this 1-ton pile of metal and motors into some living, breathing, mechanical creature to give her a personality, a curiosity, and then sometimes a complete indifference to the people around her, just like any other zoo animal. And really, it was challenging because the original thing done in a lab setting with one person and one robot in a closed, contained environment is a completely different ask for a robot responding to a crowd of people a continent away for 6 months. So there was a lot of engineering that had to be done, including changing the whole sensing system. So Mimus, she doesn't see you through her face. She sees you through the ceiling, and she has a bird's eye view of the people around her enclosure. And what she's looking for are some different hallmarks of our body and our body language. So here, this is actually what she sees. These are actually a bunch of people, these blobs here. And because she's looking down and she sees depth, she can see your head and your shoulders and your hands that are around, and we can extract some useful information around it. So for example, Mimus knows where you are in relationship to her. So if you are there and maybe you've been there for a while and you start getting closer and closer and closer, maybe we can infer that there's some sort of bond between you and her forming, some trust, and that Mimus should begin to favor you out of everyone in the crowd to go visit, right? And then maybe you just stand there and you're getting a little boring. And so why should she pay attention to you? I'm going to go look at the small person moving around that's jumping around and waving their hands. That's likely a child over there, and go play with them. So that was one of the big engineering challenges, as well as the experiential challenges of getting a robot with one body and one face to begin to address and engage a whole crowd of people without alienating anyone. And so once Mimus could see a crowd and find the most interesting person in that crowd, now she needs to move. And for me, what I want to really focus on is pushing the limits of this robot. If it was really born in the wild, it wouldn't have any sort of attachments onto it, any sort of faces or screens or things that make robots look like people. It would just have its own body to communicate. And so I really focused on how do we just use 3 simple ingredients, her posture, her motion, and the sound of her motors to breathe life into a piece of manufacturing equipment. So this is Mimus brought to life at the Design Museum in London. And I think part of the strange appeal of this machine is just how something that is so alien to our own biology can still seem so lifelike and so like us. This machine, I think, is really a vessel that is collecting our own emotions and projecting back onto us. So while it moves, it's not necessarily feeling, it's not necessarily thinking, but it is reflecting bits and pieces of our own humanity back onto us. When she gives you a gentle nod or a curious sniff or an exuberant lunge, you begin to feel that that machine is looking back at you, and you start to lay the foundation for connection and understanding. And really, at the end of the day, we are all hardwired to connect with animate things. But for me, especially being an ocean away after deploying this installation in a different country, it was incredible to see the range of emotions that a robot, just by moving and just by posing and just by torquing the sound of its motors in the right way, could elicit a whole range of emotional responses. So here's some of the unsolicited feedback I got through social media on the project. And people would sometimes see her twerk and they would find her friendly. And then some people would hear her chirp a bit and find her curious. And then there were also some people that would actually go out and tease her a little bit. And then there were plenty of people with other more lewd suggestions for their relationship. And at the end of the day, there's and kind of like even more importantly, there are these people that felt this kind of tension, this trust, and the kind of creepy factor that this big, loud, enthusiastic machine is actually paying attention to them, And why shouldn't they? Why shouldn't they have this kind of disconnect? It's really an odd sight to see a piece of manufacturing equipment that's actually attentive to you. So Mimus was really an amazing opportunity for me to explore what it's like for one robot to be surrounded by many, many people. And this next project, Manus, began to explore many robots with many people. And for this project, this was completed just last year in September, and the World Economic Forum invited me to create an installation that spoke towards the fourth industrial revolution. This idea that how do we give a snippet of our future where intelligent autonomous machines are everywhere in manufacturing and potentially in our everyday lives. So Mimus is a set of 10 industrial robots that are programmed to behave like a pack of animals. And the idea here was to also think about this assembly line of machines and get people to sort of flip the expectation on their head. So there's a lot of things that we do with the physical design of these installations that give hints that things are not quite as they should seem. So yes, this is an assembly line of robots, but they're kind of squished together too closely that really you would never see in a factory. And instead of having kind of a usable work surface for manipulating things, it's a bed of light sort of reflecting and augmenting the amount of machines out there. So these 10 machines are all connected to one single brain. And that's a really, really unique affordance that intelligent autonomous machines have that help their experience of the world be completely different from ours. Our brains and our sensors are inside of our bodies. But for these machines, they can be distributed in the world. And so, although each of these robots move individually, they all have this innate awareness of one another because of this sensory connection, this connected robotic brain. And that kind of results in these intertwined behaviors that can ripple through the whole group as people walk by. So that these robots in Mimus, they're actually quite nearsighted. And we did that to make sure that people got really, really close to them to sort of extenuate the feeling of being surrounded by these machines. And they don't see you through their snout, just like Mimus. The sensors are distributed in the environment. But instead of having a bird's eye view, they have a worm's eye view looking up at you. And so this is what the robots in Mimus see. All of the sensors are embedded in the base along the edges of here. And they're looking for features of our body language, things like how close we are, where our head is, where our hands are. And these kind of simple hallmarks of human body language are enough to stimulate this realistic movement of these machines sort of rippling by. So this is a little bit of behind the scenes of the kinematic software that I developed to sort of manage and run these 10 robots. And so once the head or hands of an interesting person is tracked, they can be sent to this central planner, and the motion generation for all these machines for the 10 robots is sort of translated from the computer and back onto the bodies. And what's pretty incredible is like when you embody all of these technical layers, the body tracking, the simulation, the motion generation, when you embody that into physical entities and in a physical space, there are these really magical moments that occur where people's expectations with these machines begin to shift from control towards connection with the robots. So with my machines, in each of these projects that I do, I work hard to try to tease out some of the poetic experiences out of these very, very pragmatic technologies. And in doing so, I do make innovations and discoveries they're quite useful and quite practical, like software tools. But at the end of the day, I'm looking for these core human truths for exploring how these machines can be a part of our lives, how they should share our cities, our streets, and our skies. For me, that means that they need to be more than just useful, that they can't be defined by the tasks that they complete, that they have to be thoughtful and meaningful contributors to our everyday lives. And this project in particular was a new experience for me, presenting, not doing work in a lab, not presenting in a cultural institution, but actually making something for policymakers, the people who are going to decide how this technology enters and impacts our lives at a very, very large scale. And for me, what I really wanted to show these people is that our future with this technology is not a foregone conclusion, that we have it in our capabilities to choose how to use these machines, that there are other alternatives besides the probable out there. And we also have a responsibility to choose how not to use these machines, which is equally important and often overlooked. When I'm working with these machines, I often think back to this moment in time in the late 1960s, when we were really just beginning to experiment with robots. And I wonder, what would today look like if the economic forces that really favored us and pushed us towards automation instead favored curiosity, companionship, and collaboration, these kind of ideas that were being explored at a very early stage in the arts communities. I think that this is a more relevant question even more today than it was back then, because we're at that point in time where machines are not just doing things in a factory, they're not just doing things in a warehouse, but they're actually doing things that impact people that weren't a part of that decision about what they're doing. So when you order a lunch from a delivery robot, that robot crosses so many people's paths on its way to you. And so it's no longer relevant to just be defined by successfully completing a task. We need to begin to show that it's also the experiences and relationships that these machines can foster around people that begin to add value to what they do. And so my hope for this community that we're a part of artists, designers, and technologists, will be ready with more imaginative ways for the incredible ecology of machines that we're creating to augment, expand, and enhance the human condition. And I hope that you're all excited for that too. Thank you so much. So I'm not sure if we have some Q&A. We have a question right here. Do we have a mic for the...
Hi there. So you've worked a lot with eyesight as a sensory experience, but I'm just wondering if you've had a chance to explore sound as well.
Yeah, I think for me, part of sound as an input is something that I haven't worked with, but it's really an important feature that I think also goes with touch. Like when you make sounds in the environment, you're sort of indicating to other people to pay attention to there. I have thought a lot about sound and sound engineering for output, like in terms of hearing the actual motors of the machines as another layer of communication. So when Mimus, for example, when Mimus gets tired because she's just visited too many people and she's overstimulated, she goes to sleep. And the way that she moves, she rotates her last motor just a little way that creates a snoring sound that it reminded me of the pug that I had when I grew up. So I sort of did that. But I think that these multisensory experiences are quite critical, especially when there's such a limited palette of communication devices with these machines. We have another mic?
Hi, thanks. Mimus, she, Manus, 10 kind of fingers. What gender is Manus if Mimus is a she?
So I think that's a great question. I personally, I don't particularly think that robots need a gender. Sure. Manus, I sort of see as a collective of robots. For Mimus here, part of the reason to give her a gender was to, again, sort of push this idea of thinking about her as a zoo creature and not just a piece of manufacturing. And the tools I constrained myself to were her body motions, the motors, and also kind of the copy that associated with the exhibition. So calling her a she in the exhibition title, I felt was a way of shaking people out of their expectation that this is just a piece of manufacturing equipment, and to think of her more like a tiger at the zoo. We have some mics coming around.
So you mentioned as well that you see robots coming out of the aspect of just manufacturing equipment and out of warehouses and such. So as we start to see robots that are, say, preparing your food, or that you might even see in a restaurant setting, what are some of the principles or nuances you think are important to keep in mind to maybe keep that emotional connection or allow people to accept that as part of their life?
Yeah, that's a really great question. And for me, it goes back to the litmus test that I use is this robot enhancing, augmenting, expanding a human, or is it replacing what that human is doing? And we have plenty of examples of robots that are replacing human labor, and not enough diverse examples of how they're lending their superpowers to people. And I think that these intuitive and human-centered interfaces is one way of sort of transferring their amazing abilities to us.
Hi. So I was wondering, as far as I know you, sorry, I'm getting nervous. As far as like you had studied computational design, things like that. For somebody trying to get into this type of field of fostering the connection between humans and computers in some sort of way, I know that developing software as well is like kind of working with a robot itself. What do you see as like a very valuable skill that you've learned, or a very valuable skill that you would seek in the future in order to continue this type of work?
So if I can understand the question correctly, you're asking, as you're trying to figure out how to contribute into this nebulous field of art and technology, what are the right skill sets you need?
Yeah, like what are the skill sets that you've found have given you the most freedom in creating art and design? And
I think one of the biggest the most challenging part is that when you always kind of feel like an outsider. So if you're a designer, you're never a good enough programmer. If you're a programmer, you're never a good enough designer. And one of the so you're always an imposter in whatever room you're in. And one of the things that really changed for me was finding my community of people that all kind of felt like that. So those kind of black sheep in their own discipline. And I was fortunate enough to be co-located in the same spot with those people. But there's also lots of online communities that are very welcoming to people who are trying to just figure this out and figure their way out through it. And a lot of the creative coding communities, like processing and open frameworks, was essential for me to begin to build that bridge between what I knew how to do and what I wanted to know how to do.
So, what I'm wondering is if you want to expand it, then more than just like robotic arms and adding like limbs and such, other than just arms.
So, what are some of the things that you would want?
Like maybe 2 arms and a head for like.
I think that's a brilliant idea. I'd actually like to wear that too. So then I would have 4 arms and 2 heads. Then no one could sneak up on me. Great question. Do we have a second mic down here?
Hi. Hello. Hi. I was wondering. Here.
Thank you.
So the talk is robots are creatures, not things, and your definition of a robot is a mechanical mind and a mechanical muscles. I wonder if you could talk about the balance of something that's alive so something that's from this earth.
Mhm.
But these robots are born out of industrial practices, so they have to be, the resources used to make them have to be mined. There has to be a great deal of industrial processes, I guess, that need to happen before we can create that robot. But of course, that's my assumption. I wonder if you could just talk about, maybe in this preferable space, how a robot could more represent an entity that doesn't require that.
Yeah, I think if, especially for robotic arms, coming from Pittsburgh, this kind of Rust Belt city, reborn from a flight of manufacturing, that there's a lot of decommissioned, kind of retired machines that are just kind of sitting there and with nothing really to do. And the benefit of that is that they're kind of cheap, and that people are willing to do weird things with them a little more readily than the really, really expensive high-performance ones. And so we're starting to see people begin to repurpose these kind of old, retired machines for new purposes. Lots of it in film and entertainment, actually. It's been pretty exciting to see that grow out. For the newer, kind of these like newer species of machines, there are, a lot of it is kind of reinventing the wheel, where there's a new generation, and it fits that product development cycle that is quite destructive. So my hope is that with the machines that are out there, or the machines that are alive now that will be obsolete at a rapidly increasing pace, that smarter software can keep them alive and keep them adaptable to new purposes. Yes.
I had a question about like looking at Mimus and Manus.
Yeah.
They were both meant for different types of audiences, like at the design museum where people are there to kind of interact with it as like entertainment, to kind of like play with it in that way with the child like running around. And then at the World Economic Forum, which is definitely, you talked about the implications with like policymakers. Did you have a different purpose in mind when kind of creating both robots, or like in the case of Manus, the collective? And also, was the reception different? Were people more scared and hesitant at the World Economic Forum, as it like symbolized something different, as you know, in comparison to something more lighthearted as Mimus?
Yeah, I think the big difference is that there's no kids at the World Economic Forum. There's just lots of people in suits. So it definitely was a different challenge, and it was a very serious event. And so it was like the part of the goal was to crack that nut, to get people to find delight and see delight and to see playfulness as they're rushing off to their bilateral meetings. But yeah, a lot of things that for the World Economic Forum, I also was there. It was a short event. It was just 3 or 4 days, so I was able to go back into the robot's brain and tweak things throughout the exhibit. And what I noticed is that a lot of people were trying to control the robots, and they'd raise their hands and conduct them and expect the robots to behave, which is like, you know, you're powerful people in their daily lives. Like, it's kind of a normal assumption. So going back in there and being able to tweak their brain, it let me kind of like undermine that confidence in them when the robot's like, oh, we're gonna go look over here, you know. So part of this is that there's a playful tone to it, and certainly some people didn't pay attention, but the goal for all of this is to have someone take a double take, to pull them off from their busy path and agenda and have them come back and actually look at what our future with machines could be, and get them to think about how that relates to the policies that they're making.
So yeah, so you mentioned that when the participants go into the museum and play around and interact with the robots, they will have some emotional bond, which kind of based on some unexist things, which so-called this robot's intelligence. Have you ever actually show those spectators the real thing, like those code, after they sort of build up this emotional bond right after the exhibition? What do you think they would have those disappointment maybe or something like that?
Well, I did a workshop with a group of kids. Maybe you saw it in the video earlier, where I had the sort of behind the scenes on an iPad before them, and the workshop was really to get them to think about like how does the system work. And it was really interesting to see. They were part of the digital champions club of their grade 5 year. So they were like programming in Scratch and doing things with Arduino. So they had a little bit of background knowledge for it. But it was really nice to see how they were discovering before I did like the big reveal for what it was actually working. They were thinking like, well, Mimus sees you through her face. And so they'd move around and Mimus would follow her. And I'd say like, no, she's not seeing you through her face. And then she's like, well, maybe it's motion controlled. So all of them would stop and hold a pose in motion. And then the robot would still be jittering, and so they knew it wasn't there. And then I thought that like, well, maybe it's heat controlled. So they would run in place real quick and see if that would get the robot's attention. And then like at some point I looked up and they saw these blinking lights in the ceiling looking down at them. And they said, oh, what's up there? It's like, oh, are those cameras? I'm like, yeah, those are the cameras. They see you in 3 dimensions. They see you in depth. And so from then I showed them the sort of, after leaving some breadcrumbs behind to show them that. But that's more of a very educational context for it. But I was like knocked back by how quickly they began to debug and pick apart how this thing was actually made at 10 years old. I was super impressed and kind of jealous, to be honest.
Madeline, thank you. I'm curious. You seem to skirt this uncanny valley in some interesting way. Can you say a few words about that? And then also related to the last question, the other aspect was that you're in China, and I'm curious what the cultural differences might have been there. Yeah. So the uncanny valley, if folks aren't too familiar with it, it's this idea that like when something looks too human, all we see are the things that are wrong with it. It's like when you see like a really bad rendering in a movie of a digital human, all you can see are its flaws. So what I try to do is I try to avoid the uncanny valley altogether. I take a big U-turn around that valley by using robots that like obviously don't look like us. And I'm not trying to get them to look like us, but I'm trying to get them to move and behave in a way that we intrinsically understand, that our lizard brains are kind of hardwired to see as animalistic movement. And that's sort of how I make them familiar but not referential to people. So they're not really anthropomorphized, but they're more animalistic in how they move. And then the second question was, for China, yeah, it was really interesting. Like on the plane, this was in Tianjin this year, and so going from it was in Xiamen. So going from Beijing to Xiamen, I would like open up the seat back of the magazine in the plane, and there was like advertisements for robots in the plane. It was like really cool to see like industrial robots being advertised in your Sky Mall magazine. But there were some things there that I was pretty blind to. Like there's a lot of symbolic gestures, bowing, for example. That when people left, they bowed, especially because there's dignitaries from all sorts of countries that I was not anticipating, and I would have liked to have like built a little bit of recognition into, to have these Easter eggs of experiences that acknowledges different cultures. And that's something I would roll into another version of this. It's something that I wish I had the foresight to see.
So, at the risk of sounding like I want you to solve the world's problems,
I'm ready. Let's do it.
I mean, are you in a way, I mean, it's great to make people feel a friendliness with robots, and in many ways we're cheap dates. We will anthropomorphize very quickly.
Like light sockets, we're good, yeah.
We're really, but is it really like, by doing this work, is it really though addressing any of the sort of fundamental fears, I think, that people have right now that robots will replace us? Because no matter how cute they are, you may have a cute robot cleaning your house, but that's still taking a job away from another human being. So I guess how does, in your mind, how does this connect to those very real fears that many people have?
And they're real fears, and they're valid fears as well. So the data supports that there is huge displacement happening through automation. And it's hardware automation, robotic automation, as well as software automation for that. And those are some of the challenges that yeah, you're right, I alone can't really address. And what I try to do is to inspire others to sort of think of new ways for these machines to enhance, augment, and expand. So what are those things that don't replace human labor, but sort of transfer some of those robotic superpowers onto people? For my installations, there is a bit of some neutrality here, right? Because it's really trying to set the stage for someone to just prompt them to think about what they want or how they think the future should be, rather than listening to kind of existing narratives that are fearful or overly optimistic about what our future with tech is. So that's kind of the agenda behind not really imposing a particular view on it. On the idea of cute, cute is a really easy interaction technique to get people to trust robots. And a lot of what I try to think about is legibility in what these things are doing. So, for example, a robot that looks cute could also be tracking you and sending your data to some other server some other way. Does it really deserve your trust in that situation? I'm more of a favor of that a robot should be very transparent in how you should feel about it. So for industrial robots, like one of the pragmatic applications of this is that a robot that's about to do something very dangerous around a human should look very, very dangerous and trigger our flight or fight instinct to take a step back and get out of that danger zone. And that's something that has been in discussion for kind of manufacturing settings, for example, when part of the most dangerous things that happen and the most accidents that happen is when an operator doesn't realize that the robot is actually on when they go into the cell and they try to do maintenance on it. So some of these physical cues that the robots can give, again, take a human-centered approach to a person not having to understand the robot, but the robot really understanding the person and what they need to stay safe.
I love this, but I have a question, because a lot of what you're doing is external and large. Have you worked with any internal or nanotechnologies?
I would love to. No, I haven't. I haven't worked with any. The scale, I think, is really important, and maybe that is my bias as an architect, that a lot of what I think about is how the body in space responds to a machine, or how a machine can get the hypersensitivity to how we move and internalize that in a meaningful way. But nanotechnology, I think, is really, really exciting. I have a total blind spot to it, but it's super, super fascinating.
One of the things I got out of today was that the sense of the possibility of collaboration, if we could have nano robots working with microbes inside our bodies. Mm-hmm.
There's different scales of that being explored. Maybe not nano, but this idea of I don't really like the term, but swarms of robots working collaboratively to do the task together. That is at a scale that we can see with our eyes. That's really interesting, and that has implications at that more chemical scale.
Thank you.
Unfortunately, I love it. There's so many questions. Phenomenal. We're out of time, but I think we want to give the last question to someone who's been here from the very beginning, Eric Paulos, right here in the front. Can we get him a microphone? This gentleman down here. I saw his hand go up, and I know he's going to ask a great last question.
Oh no, trouble. Okay. Thank you, Madeline. That's beautiful work. Thank you for sharing it with us. I actually want to know a little bit more about your artistic kind of decisions in this, because I find them really fascinating and exciting. And it's two sort of different things. One is that I'm reminded of actually this is sort of from Mark Pauline, who did Survival Research Labs. He always talks about he wanted to sort of showcase what the machines did when you weren't around and sort of what they would really want to do if we weren't controlling them. And I see some elements of that, but certainly like you've thought a lot about this, but what should they be doing when we're not around? And the other question is, you are taking them out of this kind of industrial setting, and there's this kind of sameness and this repetition, and you brought us this really great visual analogy of going to watch like a zoo or having these, and I think if you go and you see some penguin exhibit, and after a while they seem the same, and then there's like a difference, and one is a little more curious, and one is sort of falling over, and I'm wondering if you thought about bringing that difference, or if that's in here, and I keep looking for little variations, or how as an artist you approach that is really fascinating to me, if you could share any of those thoughts.
Yeah, for this project in particular, so each robot has some individual controls to its the parameters that stimulate it in a certain way. And so I did play around with having one be like extra enthusiastic and in your face and like really, really wants to meet you. And another one like losing interest and being too cool to really engage. I'm not sure if that really communicated that well, if that difference really happened, but thinking about these kind of like alpha and beta behaviors for multi-robot systems is something that I think is pretty interesting. And I've been thinking a lot about and chewing over in some new pieces that work with flying robots.
And also, what should they do when we're not around? Like, when there's no people or you're very far away, how do you kind of get people engaged, or even if the museum's closed, for example?
Yeah, I mean, for me, I put the robots to sleep. So they had almost like a video game. They had an energy level and an emotional energy level. And when they expended it, they had to recharge by going to sleep. And it was kind of nice to have that stark contrast between this kind of slumbering, quiet robot kind of in a compacted position, kind of tucked into itself, almost like a swan, and then it lunging out towards you to say, "Hello, I'm awake." That was really useful in having a little bit more variety and spice into the interactions. But the goal as well, especially for a 6-month exhibition, is how do you get people to come again and have a different experience and have it not seem animatronic, like it's a small world after all. And so having these kind of generative behaviors that are all kind of stimulated by its environment is one way of having the same flavor of movement, but still having it be really contextual to the moment there.
Thank you.
I think that point about having your energy level monitored is a great idea. I think we should all have such a thing. Especially now that I'm getting old. I really appreciate this is wonderful. Thanks everyone who organized. Thanks everyone for coming out tonight. Thank you, Matt.
Thank you for having me.